If this is your first time here, this isn't a standalone video. It's one chapter in a complete story, the entire history of evolution, from the first replicating molecules to you. Every organism we mention is your direct ancestor, not a cousin species, not something similar, your actual lineage, an unbroken chain connecting you to the origin of life. That's what makes this different from every other evolution content out there. Most of it is scattered fragments, dinosaurs here, early humans there, the Cambrian explosion somewhere else, all disconnected. But they're not disconnected. They're all chapters in the same story, your story, and you can't understand any link without seeing what came before it. Lungs don't make sense without swim bladders. Mammals don't make sense without reptiles. Each chapter builds on the last, and nothing appears out of nowhere. 4 billion years of your deep history told as one continuous thread. If that sounds interesting, Chapter 1 is in the top right corner. I'd recommend starting there. If you've been watching from the beginning, you already know what this is. Let's keep going. Our lineage now exists as bipedal apes living in African woodlands and forest edge environments around 6 to 7 million years ago. These animals walk upright habitually, not occasionally like chimpanzees, but as their primary mode of locomotion, yet retain long arms and curved fingers, indicating they still climb trees regularly. They have brains slightly larger than chimpanzees relative to body size, complex social groups, and the cognitive capacity to use simple tools. Over the next 6 million years, this lineage will undergo dramatic changes. Full skeletal adaptation to bipedalism, brain size tripling, dependence on stone tool technology, evolution of language, and development of cumulative culture. This chapter traces that transformation through a series of species, each showing incremental changes that collectively created modern humans. The earliest confirmed hominin, a member of the human lineage after the split from chimpanzees, is Sahelanthropus tudensis, dated to 7 to 6 million years ago from Chad in Central Africa. The fossil is a skull showing a mix of ape-like and human-like features. The face is relatively flat, unlike the protruding face of chimpanzees. The canine teeth are smaller than chimpanzee canines. Most importantly, the foramen magnum, the hole where the spinal cord enters the skull, is positioned toward the bottom of the skull rather than toward the back, indicating the head balanced atop a vertical spine. This is the signature of upright walking. Why bipedalism evolved remains debated, but the advantages in woodland savanna environments are clear. Walking upright is more energy efficient than knuckle walking when covering long distances across open ground. It frees the hands to carry food, tools, or infants while traveling. It raises the head higher, improving sight lines over tall grass for spotting predators or locating food resources. It reduces sun exposure. A smaller surface area faces directly overhead sun, helping with heat regulation. These advantages weren't individually transformative, but collectively they made bipedalism beneficial enough that natural selection favored individuals with skeletal changes, improving upright walking efficiency. By 4.4 million years ago, our lineage consisted of Ardipithecus ramidus, known for extensive fossils in Ethiopia. Ardipithecus was fully bipedal when on the ground, with a pelvis showing clear adaptations for upright walking. The pelvis was shorter and broader than in apes, repositioning hip muscles to stabilize the body during the single-leg stance phase of walking. The foot had a divergent big toe, more mobile than in later hominins, still useful for grasping branches, but the other toes and the ankle showed adaptations for bipedal walking. Ardipithecus was small, about 120 centimeters tall and 50 kilograms, lived in woodland environments, and ate primarily fruit, leaves, and nuts. The Australopithecus genes appeared around 4 million years ago and diversified into multiple species between 4 and 2 million years ago. The most famous is Australopithecus afarensis, known from hundreds of fossils, including Lucy, a 40% complete skeleton dated to 3.2 million years ago. Australopithecus afarensis was clearly bipedal, with no remaining doubts. The pelvis was fully adapted for upright walking, the legs angled inwards at the knee to position feet under the body's center of mass. The feet had lost the divergent big toe and developed a longitudinal arch for efficient push-off during walking, and the spine had developed the S-curve characteristic of humans that positioned the head over the body's center of gravity. Australopithecus still had relatively small brains, about 450 cubic centimeters, roughly chimpanzee-sized, and relatively large teeth with thick enamels suited for chewing tough plant foods. They lived in environments ranging from woodland to more open savanna, traveled long distances on foot, and probably still climbed trees for safety at night or to access certain foods. Stone tools had not yet been found clearly associated with Australopithecus, though they may have used unmodified stones as hammers or anvils, and certainly used perishable tools like sticks that don't preserve. Around 2.8 million years ago, the first members of our own genus, Homo, appeared in East Africa. The earliest species, Homo habilis, showed key advantages over Australopithecus. Brain size increased from 600 to 700 cubic centimeters. Teeth and jaws became slightly smaller, and crucially, Homo habilis is associated with the first definitive stone tools, the Oldowan industry, consisting of simple flaked stones creating sharp edges for cutting meat and processing plant foods. Stone tool manufacture requires understanding that striking one stone against another at a correct angle will detach a flake with a sharp edge. This seems simple, but requires cognitive abilities most animals lack. The ability to envision a desired outcome, plan a sequence of actions to achieve it, and possess fine motor control to execute precise strikes. Tool use isn't unique to humans. Chimpanzees use sticks to fish for termites. Sea otters use rocks to crack shells. But manufacturing tools to a standardized pattern that's taught and transmitted across generations represents a cognitive threshold our lineage crossed around 2.6 to 2.8 million years ago. Tools changed everything. Sharp stone flakes allowed access to carcasses, cutting through thick hide to reach meat that would be inaccessible otherwise. Access to meat, a calorie-dense and nutrient-rich food source, provided the energetic resources to support larger brains. Brains are metabolically expensive tissue, consuming about 20% of resting metabolism in humans, despite representing only 2% of body weight. The shift towards higher quality diet, including meat and bone marrow, made this expense sustainable. Homo erectus appeared around 1.9 million years ago and represents another major transition. Brain size increased to 900 to 1100 cubic centimeters. Body proportions became fully modern. Tall, long legs, short arms, narrowed pelvis, and barrel-shaped chests, all adaptations for efficient long-distance walking and running in open environments. Homo erectus manufactured more sophisticated tools, the Acheulean industry, featuring symmetrical hand axes carefully shaped on both sides, requiring planning and mental templates. They controlled fire by at least 1 million years ago, using it for cooking, warmth, light, and protection from predators. Fire and cooking are transformative because cooking pre-digests foods, breaking down tough plant fibers and denaturing proteins, making nutrients more accessible and reducing the energy needed for digestion. Cooked food can be chewed and digested faster than raw food, allowing further reduction in jaw and gut size while still extracting sufficient nutrients. The energy saved on digestion could be allocated to brain growth and maintenance. Homo erectus was the first hominin to leave Africa, spreading into Asia and reaching as far as Georgia, China, and Indonesia by 1.8 million years ago. This required cognitive sophistication for navigating unfamiliar environments, solving novel ecological challenges, and possibly coordinating group activities through some form of communication beyond what earlier hominins possessed. Homo erectus persisted for over 1.5 million years, making it the longest surviving hominin species beside our own. Between 800,000 and 300,000 years ago, Homo erectus populations in Africa evolved into forms transitional between Homo erectus and later hominins, sometimes called Homo heidelbergensis. Brain size increased to 1,200 to 1,300 cubic centimeters, approaching modern human size. These populations manufactured even more sophisticated tools, constructed shelters, and may have begun using symbolic markers, orche pigments whose purpose isn't clear but may relate to decoration or communication. Around 300,000 to 400,000 years ago, hominin populations in Africa, Europe, and Asia began diverging into distinct lineages. European and Western Asian populations became Neanderthals, with brains as large as or larger than modern humans. Sophisticated stone and bone tools, evidence of caring for injured group members, and burial of the dead suggest symbolic thought. Eastern Asian populations became Denisovians, known primarily from DNA and few fossil fragments. African populations became anatomically modern Homo sapiens. The oldest fossils of Homo sapiens with fully modern anatomy date to around 300,000 years ago from Morocco and Ethiopia. These early modern humans had high, rounded skulls, housing brains averaging 1,350 cubic centimeters, small faces with reduced brow ridges, prominent chins, and fully modern body proportions. But early Homo sapien behavior wasn't immediately modern. For over 200,000 years, they manufactured stone tools not dramatically different from those made by contemporary Neanderthals or late Homo erectus populations. The transition to behavioral modernity, the full suite of behaviors characterizing recent and living humans, happened gradually between 200,000 and 50,000 years ago. Archaeological evidence shows appearance of symbolic artifacts, shell beads used as ornaments, orche pigmentations for decoration, engraved patterns on stones and bone suggesting abstract thought, more sophisticated and diverse tool types including specialized tools for specific tasks, long-distance trade networks moving rare materials hundreds of kilometers, and eventually, around 40,000 years ago, representational art including cave paintings and carved figurines. Language almost certainly evolved during this period, though its origins remain unclear because a language doesn't fossilize. The anatomical prerequisites existed. Homo sapiens had a descended larynx, allowing production of diverse vowel sounds. Neural control of breathing allowed sustained vocalization, and brain regions specialized for language production and comprehension. Genetic evidence shows modern humans possessed versions of genes like FOXP2 involved in language ability that differ from versions in Neanderthals, suggesting language-related evolution in our lineage within the last few hundred thousands of years. Language is transformative because it allows the transmission of complex information between individuals and across generations without requiring each individual to learn everything through personal experience. A group with language can accumulate knowledge, how to make specific tools, where seasonal food sources are located, which plants are medicinal, how to navigate terrain, and pass the knowledge on to children verbally. This creates cumulative culture, where each generation builds on previous generations' innovations rather than starting from scratch. Around 70,000 to 60,000 years ago, a relatively small population of Homo sapiens, perhaps a few thousand individuals, left Africa and began spreading into the Middle East, Asia, Europe, and eventually Australia and the Americas. This expansion happened in waves over tens of thousands of years. When Homo sapiens encountered Neanderthals in Europe and Western Asia, the groups interbred. Modern non-African humans carry 1 to 2% Neanderthal DNA. Similarly, inbreeding with Denisovians occurred in Asia, with some modern populations carrying Denisovian DNA. By 40,000 years ago, Homo sapiens was the only surviving hominin species. Neanderthals went extinct around 40,000 years ago, possibly outcompeted by Homo sapien populations with slightly more efficient hunting strategies, more sophisticated social networks, or technological innovations. Denisovians disappeared around the same time. Late surviving populations of small-bodied hominins, like Homo floresiensis in Indonesia, persisted until perhaps 50,000 years ago before vanishing. The last 40,000 years saw Homo sapiens spread to every continent except Antarctica, adapting to environments from Arctic tundra to tropical rainforests to high-altitude plateaus. population size grew from perhaps a few million globally 10,000 years ago to over 8 billion today. Technology accumulated exponentially. Agriculture beginning 10,000 years ago, metalworking, writing, cities, industrialization, and now digital technology. Social organization grew from small bands of related individuals to chiefdoms, states, and global interconnected societies. But genetically and anatomically, we remain essentially unchanged from the Homo sapiens that left Africa 60,000 years ago. Our brains are the same size, our bodies have the same structure, our genes differ by fractions of a percent from those ancient populations. What changed isn't our biology, but our culture. The accumulated knowledge, technology, social structures, and symbolic systems transmitted through language and teachings across generations. This is the endpoint of our lineage. From self-replicating chemicals and hydrothermal vents 4 billion years ago, through the first cells, through eukaryogenesis, through early animals, through fish and developing jaws, through the transition to land, through synapsids becoming mammals, through primates entering trees, through apes returning to the ground, through bipedal hominins expanding across Africa, to modern humans spreading globally and building civilizations. Every feature you possess, your cells with mitochondria and nuclei, your backbone and 4 limbs, your warm blood and body hair, your forward-facing eyes and grasping hands, your large brain and capacity for language, traces back through this unbroken line of descent, each feature arising in response to specific challenges faced by specific ancestors in specific environments. You are the current result of 4 billion years of continuous evolution, the temporary endpoint of a lineage that has never once been broken since the origin of life itself.